Hello chemists, so today we'll be learning about Gay-Lussac's gas law. Let's begin.
What's up guys? Today we're going to learn about gas law.
And this gas law is Gay-Lussac's law.
At the end of this video, you are going to learn all about who Gay-Lussac is.
Know the relationship between pressure of a gas and its temperature.
And know the formula of this gas law and to be able to solve problems using this formula.
Let's begin.
First of all, let us know the man behind this gas law. Gay-Lussac, or known as Joseph Louis Gay-Lussac. He is a French chemist and also a physicist. He was the one who discovered the relationship between the pressure of gas and absolute temperature. That gave him the idea to make his own gas law. So, let's learn about the gas law.
Gay-Lussac's gas law states that the pressure of the gas at a constant volume is directly proportional to the absolute temperature. In this law, if the temperatures goes up, the pressures also goes up. If the temperatures goes down, the pressure also goes down. This law is used when observing a gas under changing temperature and pressure. Let's have an experiment. Experiment. The materials needed are plate with water and candle, glass and a light. First, light the candle. Then put the glass onto it and wait till
Here is the formula of Gay-Lussac's law. P sub 1 over T sub 1 directly proportional to P sub 2 over T sub 2, where P sub 1 is the initial pressure, P sub 2 is the final pressure, T1 is the initial temperature, and T2 is the final.
You might have realized that Gay-Lussac's law is pretty similar to Charles' law. Yes, the only difference is, in Gay-Lussac's law, it has a constant volume, while in Charles, it doesn't have.
Let's do an exercise. Bring some pen and paper with you. Let's begin.
Let's answer this problem. The problem is, the pressure in a sealed can of gas is 235 kilopascals when it sits at room temperature or 20 degrees Celsius. If the can is warmed to 48 degrees Celsius, what will the new pressure inside the can be? So, the formula that we will use is P sub 1 over T sub 2 is equals to P sub 2 over T sub 1. But before that, we should rearrange the formula to get the final pressure. First, let us write down the given. P1, T1, P2, and T2. P1 here is 235 kilopascals. 235 PPA. Then our initial temperature is the room temperature, which is 20 degrees Celsius. And the question here is, what is our new pressure? So it is the missing variable. Then here, given the temperature, the final temperature, which is 48 degrees Celsius. But before that, let's change the temperature into Kelvin. First, we need to add the Celsius to 273, which is now 293 Kelvin. And here, we also need to change it to Kelvin, which is, we should add to 273 is equals to 48 plus 273 is 321 Kelvin. 321 Kelvin. So we have our givens right down here, and let's move on to solve the final pressure. So to find the final pressure, we should rearrange this formula so that we can find the final pressure. So let's do this. Substitute the values in this formula. P1, which is 235 heat PA, over our initial temperature, which is 293 Kelvin, equals to P2, which is our missing variable, there. Then substitute our given final temperature, which is 321 Kelvin. So to find the missing value, which is P2, we must cancel this part of the equation, the formula. So we should multiply it by itself. 21. Also here, 321 Kelvin. So this can cancel the value of the temperature in. So here we can have our formula to get the final pressure, which is 321 Kelvin multiplied by 235 kPa over 293 Kelvin. So let's solve the problem. First, we must multiply this one, the final temperature multiplied by the initial pressure, which is 321 multiplied by 235, which is 75 435. We need to cancel first the units, which is Kelvin. Then here left is kPa over 293, equals to the final pressure. Then you divide it to 293. So we came into the answer of 257 kilopascal. So that's our final pressure that was missing. Yeah, that was missing. And that's all. Thank you. We have here another problem. A car tire has a pressure of 2.38 atmospheric measure at 25.3 degrees Celsius. If the pressure inside reaches 4.08 atmospheric measure, the tire will explode. How hot will the tire have to get for this to happen? Report the temperature in degrees Celsius. So first, we must write down our given values. Our initial pressure, which is 2.38 atmospheric measure, our initial temperature, which is 25.3 degrees Celsius. And remember, in gas laws, you should use always in Kelvin. You should always convert rather the temperature in Kelvin. Always remember that. So we add this 273 to this degrees Celsius to make it, to convert it rather to Kelvin, which is, the final answer is 298.3 Kelvin. So our final pressure, which is 4.08 atmospheric measure, and our missing value, which is our final temperature. So first, we use this formula, the LUSSAC'S formula, which is P sub 1 over T sub 1 is equal to P sub 2 over T sub 2. So the easiest way to rearrange this formula to get our missing value is to cross multiply this. So cross multiply this here and this here. So we derive at an answer of P sub 1 multiplied by P sub 2 equals P sub 2 multiplied by P sub 1. But first, we must divide each side to the initial pressure to get our final solution or formula, right? So, cancel this P1 or P1 cancel, divide both sides by pressure, initial pressure. Then here is our derived formula. Now, we're going to substitute this in order. So first, T2 is equivalent to our final pressure, which is 4.08 atmospheric pressure multiplied by our initial temperature, which is 298.3 Kelvin, over our initial pressure, which is 2.38 atmospheric pressure. So here we can see two units have the same two units are the same rather, which is the atmospheric pressure. So we must cancel this unit, and left is the unit of Kelvin, which is for temperature. So now we multiply these two and divide this to the initial pressure, so we get our value to 511 Kelvin. Easy, right? That's all. I almost forgot. It said there in the question that you should convert your answer to degrees Celsius. So here we have Kelvin. We should subtract it with 273. So we have 62 degrees Celsius. There, that's the final answer. I hope you learned for today. Bye.
Thanks for watching! Don't forget to like and subscribe and click the notification bell. To perform the experiment, the materials needed are plate and water, and a match. Thanks for watching! Don't forget to like, subscribe, and click.